Hello, I'm Karen Quattromoni, the Director of Public Relations for Object Management Group, OMG. Welcome to our OMG podcast series. At OMG, we're known for driving industry standards and building tech communities. Today, we're focusing on the Augmented Reality for Enterprise Alliance area, which is an OMG program. The area accelerates AR adoption by creating a comprehensive ecosystem for enterprises, providers, and research institutions. This Q&A session will be led by Christine Perey from Perey Research and Consulting.
Hello and welcome. It's my pleasure to be hosting a fireside chat today with my friend and colleague. Thank you for joining me. We're going to be talking about generative AI and augmented reality. Please introduce yourself to our audience.
Okay, my name is Joaquim Jorge, and I am the UNESCO Chair of AI and Extended Reality since 2022. I am a professor at the Instituto Superior Técnico, the School of Engineering of Universidade de Lisbon in Portugal. And I am also organizing a conference called AI XR in Lisbon next January. And my interests include the applications of extended reality and artificial intelligence to medical scenarios. Indeed, we are working on a couple of projects with my collaborators, and I've been involved for a long time in related groups in IEEE and ACM, including SIGGRAPH, IEEE VR, and another interesting conference for this topic, which is the Mixed and Augmented Reality ISMAR, also an IEEE-sponsored conference.
And ISMAR, I am a loyal ISMAR attendee. So I plan to go in 2024 in Seattle. Hope to see you there. So let's get started. I wrote in these trends that I plan to monitor in 2024 that it's obvious that AI, specifically generative AI, and augmented reality will intersect. But I don't have any hard evidence of that. So the question I have for you is, do you have evidence of this as a trend? Is it already beginning, or is it something that will begin in the next few months or years?
Yeah, that's, as Mark Twain used to say, it's a bit difficult to predict, especially the future. So, indeed, there are trends, and I personally am interested in this idea of using generative AI in conjunction with extended reality in several domains. As an example of the projects we are tackling in my research group, we are looking at having an interactive anatomy teaching setup where we can use data from anatomical data sets that can be visualized in extended reality, and then people can interact with these data sets, and then you can use large language models to provide explanations and discussions about different anatomical structures. And we foresee that this can be used for teaching purposes. Of course, the problem now with generative AI is that people are not sure how to control the quality of the explanations offered or the references used. Although the great enticing feature in large language models and generative AI in general is that you can generate articulate natural language, and that has been something, and in a sense, a little bit of a free form. Mm-hmm. And that's the biggest challenge with generative AI systems is how much you can expect them to be faithful in terms of the quality of the data and the explanations they offer. But the attractive feature is that you can make them very conversational.
So So what if I could use a word that's now common in the, you know, in the parlance of our times, is hallucinations.
Yeah.
So we can't get 100% assurance that there are no hallucinations. And in medicine and in many fields where there is risk, we cannot afford to rely on something in a production environment where it could be wrong. Yes, so you're saying that that is a very, very substantial obstacle to adoption of Gen AI at this time.
Yes, that's one of the largest, one of the tallest hurdles and a significant challenge.
What
Because,
about using
yes,
what about using, instead of using a public trained, but using a, 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 a a model that's trained only on a very controlled data, you know, on the data sets of a company, or the data set only of that one patient, or I don't know, one type of a heart failure or something like that. What about constraining the model's learning? Does that help?
well, that's an interesting question, because you see, due to the nature. So let's you have things like stable diffusion and trained language models. The problem that people are finding out with these large language models, it's not enough to constrain the training set, because at the core, these systems are trained to deliver the most plausible stream of words in a statistical sense. And the problem is that statistics only tells you what's the most likely word to show up in a tree. And if you could liken some of this to a stream of consciousness type of discourse, where the person, the agent, the system delivering this speech is really not constrained by things like common sense,
Mhm,
scientific
mhm.
knowledge, understanding the prompt or the question,
Experience,
the
right?
experience.
Experience of the doctor. Yes.
So we are looking in terms of research at looking at having more robust knowledge representations that can adequately be used to constrain the text, the sentences output by these models. And that's still something that it's a bit in its infancy. The
Mhm.
project is not less than a year old.
Yes,
But
yes.
the idea is that you can use some graph representations of knowledge, like knowledge graphs, and then use these knowledge graphs to see what are the plausible derivations and weed out the implausible. This is a promising avenue, but we still have to work out the technical implications of this approach.
Excellent, excellent. So this research that you're doing, um, how do you deliver? So what's the role of augmented reality in the research that you're doing? I guess that's
A little bit. Okay, that's an interesting challenge there. So I prefer to talk about extended reality, where we discuss where we choose between virtual, mixed, or augmented reality,
okay.
depending on the
Mhm.
scenario and applications. I feel that one of the most promising domains would be in training in industrial scenarios, where you can use augmented reality as an advantage to make the interaction more natural and less contrived, and actually uh, using the capabilities of afforded by interactive, augmented, and virtual reality settings You can provide instructions in real time, provide focused and targeted explanations about procedures that need to be followed. And that's also another promising avenue that I'm exploring with one of my students, doctoral student, in using augmented reality to provide examples using animations and so that people can understand more complex tasks. This can be, for instance, employed in surgery, where you can use augmented reality and large language models to provide guidance and support for surgical teams. And
Yes.
that's a 3 to 5 year vision, because those tasks are complex, and more important than that, the scenarios are very risky.
Yes,
You,
exactly.
uh,
Yes,
the
yes.
cost of,
Risk to life is the highest risk there is, right? I
exactly.
mean, that is that's the ultimate risk. Okay. Um, and the benefits, of course, of joining these two is that, in fact, the AI may be able to detect and anticipate problems that the human who is
Yes,
very focused on their task may not have anticipated sufficiently quickly or as far enough in advance to think about it and to make corrective actions. Yeah.
yeah. Yes, another interesting application. People are increasingly talking about the emergence of applications of artificial intelligence and machine learning to healthcare. Diagnostics. We are working on a fascinating application called Colon VR, which is to replace the traditional means of diagnostics, and are going to start. Have been working on a project that uses virtual and augmented reality to improve diagnosis there, because it's time-consuming and intricate medium of analysis, and the possibilities there are very fascinating. You can use what you suggest, which is to have machine learning algorithms to find and identify possible lesion loci, and then direct the attention of the doctor, the physician, the radiologist to those spots, and then have the radiologists complement or inspect those spots, and using their knowledge and training, see if there is reason for providing
Intervention. Yeah.
diagnostic. Yes. And there, I feel that the immediate future and the medium-term future of artificial intelligence and extended reality is to make this cooperation between experts and even lay people and machine learning algorithms more intimate and productive.
That is very well said. Very, very, very insightful. And it leads me naturally to another trend that I wrote about, which is exactly as you're saying, the video signal from the user's glasses in real time is analyzed by the AI, and something new, different, is provided to the user. But in the trend that I am hopeful about is that the AI can segment the scene that's in front of this user. Yes, segment the scene to objects, to statues, or to a lesion, but also can identify faces. And then that the AI can um, remove information from that frame by frame, to remove perhaps the faces of the people or some very valuable intellectual property that could be exposed if this video were used. And so I think that the potential to increase privacy, either in the workplace or in public, could be another driving force for using AI on the video after the AR user has been there. What do you think of that?
That's a very, very significant challenge. And in the medical field, it's kind of some biomarkers are kind of very difficult to remove from the data. If people suffer from a very rare disease, then just diagnosing that disease on a medical data set can provide clues as to the contexts, race, social and geographical origins of the person being diagnosed. So privacy really is a tricky subject, and there are significant challenges. Of course, what you suggest is already being done offline in contexts such as Google Earth and Google Street View, where things like license plates and faces of people and sometimes even animals are being elided or blurred from the pictures. But that sometimes can be not enough. So that's something that we are very, very treading very carefully here. So far in my research, we have tried to use public domain data sets where other people have focused on the privacy issues, because otherwise we have really to, when you do research in these areas, we have to be very, very, very careful about privacy contents.
Yes, exactly. And so that limits the data sets that you can train on. It from the very beginning, it says you won't. Well, anyway, you understand the problem very well, much better than me.
Well, if I may add something to this discussion here. We are focusing mostly on imageology-based diagnostics, because that's where the advantages of extended reality become more obvious, where you can interact with images, with 3D images, with data sets where the superior features of the human vision system can be put to good advantage.
Yes.
Collaboration or under the controlling machine learning algorithms. Now, what makes it interesting is that sometimes the reference data that you use can be very subjective. And let me give you a concrete example. We are dealing with X-ray radiographs of chest X-rays. That's the current subject of a project that we are undertaking here, where we are trying to provide a virtual reading and training room using virtual reality for both seasoned and apprentice radiologists alike. And the interesting thing about the baseline data is that if you present the same radiograph to 5 different radiologists, you'll get 5 different analyses and diagnoses. It's a very, very subjective means of diagnostics, and that's one of the big hurdles that we have to overcome here. Is what really is ground truth?
Sure.
So this makes our life much more interesting.
Yeah, it certainly does. It certainly does. Well, in research, it's always a question of where does the research end, and then can you take the technology transfer to commercial success? Is your department at all involved in any technology transfer projects? And where would you recommend that companies begin if they're looking into this?
Right, that's a very interesting question. For the healthcare industry, our main challenge is to make sure that our findings are ecologically valid. That is, that they find application in the real world. And to that end, we've been working hard on getting the collaboration of physicians, clinicians, imageologists, And we are working with SMEs that are specializing on the problem domains that we want to address.
Yep. Mm-hmm.
And the advice I can give is that you should start early and not be, and the word technology transfer can sometimes be very misleading because it assumes that we developed kind of a mature product, and then it's just the marketing department and the people in the companies that should take care of that. None can be further from the truth. The right way to do technology transfer is to involve the stakeholders from the inception,
Yeah.
talk to them, because this is applied science,
Right.
not cosmology or some other more exoteric domain, and work with them to make sure that A, you understand the problem, and B, that you can put their knowledge to the best use, because one thing is computer science, and another thing are the problem domains where we need to bring our the knowledge of extended reality and artificial intelligence to good use.
The real world,
Yes.
we call that the real use cases, not the ones that we invent in our minds.
Exactly. Knowing the tools does not make you a very good carpenter. You also have to be knowledgeable about wood.
Exactly. No, it's a very, very good point that you raise. All of this has been a very interesting discussion. I really appreciate your coming and joining us and sharing your knowledge, and I look forward to learning more from you and with you as an engaged part of your community. It's great. Thank you.
Sure. Thank you very much for having me.